Now, we've taken a moment while we were paused to enter in this data into our calculator. Now, one thing you may notice is that when we look at the data, it's not entered in exactly the same way. So I do have 78.9, 3.9, all the expected percentages on the list 1, but list 2 we converted because these were counts out of a sample of 300. So 189 divided by 300 was 63%. And then for list 3, we did the formula of observed minus expected squared over the expected. So the last thing we need to do to remember is to then sum those things up. All right, so to do that, we're going to exit our list here and go to we want to sum our list. Where was that? Where is it? I thought we found it somewhere else too. List. Oh, right above stat. Second list. Oh yeah, over to math. Sum, number 5. But it's also under catalog. So we want the sum of which list? L3. That's right. Woo! That's a big chi-squared, right? Pretty large chi-squared. I think that's pretty large, 98.1. And so as I consider what that means, so our chi-squared, and what's our degrees of freedom? So there were there were 1, 2, 3, 4, 5, 6 different categories that we were using. 6 things where we had an observed and an expected value. So that's our N. Our N is 6, but our degrees of freedom is 5. It's 1 less than the value of N. And so right off the bat, this large, we should probably know right off the bat that it's almost impossible to happen by chance. If we want to calculate the actual probability that it happens, then we're going to go to our distributions. And we want chi-squared CDF. What's the cumulative density for this chi-squared? Number 8. That's correct, 98.11. So what's the probability it's going to be bigger than that? For 5 degrees of freedom. You did not get 1.32. You do not have to write it down. So we got 1.3 times 10 to the negative 19th. So we can see that this population in 94 was not like what it was back in 1981.